Okay, maybe about 20, so you can imagine if I did the whole lesson like that, that'd be kind of annoying, but nevertheless, we're going to get into chapter 3 here, talking about the cycling of matter in the biosphere. So we're going to start off, like I said there, or wrote there, we're going to talk about the hydrocycle and the carbon cycle today, and next lesson we'll do the nitrogen cycle and the phosphorus cycle. So, starting off here, hydrocycle. How does water cycle on the planet? Well, it comes in a variety of forms here. So the movement of water can be through precipitation. So this would be rain, snow, sleet, hail. So this would be rain falling from the atmosphere. We then have standing water, which would be our lakes, our swamps, our sloughs, our rivers, our streams, etc. We also have water that sinks into the soil, going through our groundwater. We of course have water in our oceans. We then have evaporation, so water moving back into the atmosphere, usually when it's heated up through solar energy. Water vapor, which would then be in our atmosphere as well. So as this happens, this would be our condensation. So we have clouds forming and then would eventually fall again in the form of precipitation. So let's put it all together here in our cycle, and I'll highlight a few key things for you. So number one, I don't know, I always like to start with precipitation, but you can really start anywhere because it's a cycle. So clouds form in the atmosphere, and then we're going to have rain. So we're going to have rain, snow in the form of precipitation. So water falling from the atmosphere back down to the lithosphere and the hydrosphere. Okay. Some of this water will then go into lakes, it will go into streams, it will go into rivers. Some of it will even float down here into the soil and form our groundwater and our water table where that groundwater is located. Most of it will actually make its way over to the ocean here. So most of it will make its way over to the ocean. And from there, we're gonna have a little bit of movement here. Number one, we get a ton of evaporation right over the ocean. So right over the ocean, there's a huge amount of evaporation because of course we have a ton of water over the ocean. So erase that there. So runoff. There we go. We also have a little bit of evaporation over land as well. So we're gonna have evaporation over lakes and streams and rivers, etc. And we're gonna have the process of transpiration. This is where plants essentially open up their leaves and they allow water to leave. So it kind of like cools them down. It's a way for them to regulate their temperature. So this also puts moisture and water back into the atmosphere. We can also have precipitation over the ocean as well, right? Very important there. And finally, when the water is back in our atmosphere, we have the process of condensation, taking that water vapor and putting it into the form of clouds so they can fall again in precipitation. Now, this is really important because without the water cycle, essentially water would just remain in the ocean. And that would not be a good thing. We need water to be able to cycle throughout the world. So what happens is a lot of the water will end up in the ocean and it gets really salty because along the way, it's kind of eroding at banks and rocks and it's picking up salt and sediment and different particles. And when it ends up in the ocean, it ends up being really, really salty. So what happens is when it evaporates, that salt stays in the ocean and the water is purified and brought back into the atmosphere. Then wind currents will pull those clouds outward to land so we can get rain and water cycled over land and then it just flows right back to the ocean. So very, very important, this cycle. Obviously water is essential to so many different things in our lives, especially since our bodies require it for all these various chemical reactions and absorbing nutrients and vitamins and things like that. So a couple more points on the water cycle here. Number one is we have surface water or groundwater. Now remember, surface water is precipitation that collects, say, in lakes, ponds, or rivers. Groundwater is where we get this process called percolation, where water will seep into the soil. So then sometimes plant roots will absorb it and then use that for their systems and their processes. But then sometimes it goes all the way down and hits the water table there where plants might not be able to get at it. Now the water table, I've mentioned this a couple times here, it's basically the top level of where the water is located below the soil, right? So if it's a high water table, plants might be able to have roots to get in there, some shallow roots. If it's a larger water table or deeper water table, you might need longer roots to get down and get it. Problem associated with this is if the soil isn't very good at holding on to water or nutrients, as the water flows through the soil, we might have nutrients being pulled with it and being pulled down where plants can't access this. And this is the process of leaching. Now, a downside of the water cycle is it can lead to acid rain. Now, how does acid rain work? Well, when we produce factories and we produce our things in our factories and our different businesses, what happens is some of the byproducts of these businesses is salt, and of course our cars as well, sulfur dioxide and sulfur dioxide and nitric oxide. So what happens here is when these two oxides get into the atmosphere, they can combine with water. This forms a acidic compound, sulfuric acid, H2SO4, and nitric acid, HNO3. Then again, they form into clouds, rains down, and now this rain is quite acidic. Now, it's obviously not, say, melt your face off acid or anything like that, but it's a low enough pH that it can change the pH of lakes, rivers, streams, soils, and have a huge impact on the ecosystems. And this isn't happening over cities because remember, the wind is going to take it this way, so away from the smoke and away from the fumes and the emissions, over here to the ecosystems where we have lakes, rivers, streams, forests, farmland, and now that acidic rain is going to be deposited, changing the pH of all these various ecosystems. And some organisms are really, really sensitive to pH changes, so we have to watch that. So this is one downside of the hydrocycle where we as humans are negatively impacting the hydrocycle. Okay, now I want to move on to the carbon cycle. So where do we find carbon in our ecosystem? Well, we can find inorganic carbon in the atmosphere as CO2. We can find it in the ocean as well as CO2, and as well as in our Earth's crust. So this is inorganic carbon. We also find organic carbon in essentially the bodies of living things. So we right now have like organic carbon inside of us. We're made of organic carbon. And it's also found in peat as well. So what is peat? Well, it's essentially that slowly decomposing plant matter. So over time, that plant matter gets decomposed in areas like bogs or swamps where there's low oxygen. So basically the plant will die, it will be converted into peat, and over time this peat gets covered and covered and covered and covered, and through increased pressure and temperature and sedimentation, it gets pressed and pressed and pressed and pressed together till we get things like coal, oil, and fossil fuels. So that's essentially how fossil fuels are made. Basically coal, you can think of it, is just old animals and plants. So I always like to say, when you're filling up your car with gas, or when you're using oil for something, or burning coal, what you're really doing is using old plants and animals, even dinosaurs, right? Because it's millions upon millions of years that this process is compacting, and turning that decaying matter, that plant matter, into coal. So it still contains carbon, right? The carbon is still there, it's just now in a different form. But this leads into our cycle, right? This leads into our carbon cycle. So a couple things I want to highlight here. This cycle seems confusing at first. We just need to note that, okay, this is the cycle over water, and this is the cycle over land. And there's a couple mini cycles going on here. So the first cycle here involves the process of photosynthesis and cellular respiration. So photosynthesis and cellular respiration. So for photosynthesis, this will take carbon dioxide from the atmosphere to the producers. Producers will also release carbon dioxide through cell respiration and put it back into the atmosphere. Now, consumers will eat producers, which they too will undergo cell respiration. And decomposers, which are really important here, decomposers do a few things. One, they can recycle the carbon so the producers can take it up again. And two, they release carbon through respiration. And three, some of that decomposing matter, like I told you, gets compacted over time, so then we get carbon in our coal, our oil, and our gas, and our fossil fuels. So that's what's happening to the carbon in terms of the kind of food chain side of things. We have photosynthesis bringing it in, respiration taking it out, decomposers either returning it to the soil or having it compacted into fossil fuels. And the same thing's happening over there in the ocean. One difference in the ocean though is sometimes carbon will get put into sediments. So carbon will get compacted into the ocean sediments. And what happens there is over time, those sediments can build up and through geological uplift can actually be returned to the surface. And then as they're broken down by wind and rain and weathering, we can get that CO2 or that carbon returned to the soil, the water, the atmosphere, and it cycles through, okay? Now normally this cycle is fine, right? This cycle between CO2 and organic, inorganic carbon, everything's balanced. But right now things are getting out of balance, and here's the reason. We go to this side of the graph, or this side of the diagram. Carbon over here in fossil fuels, buried deep down. We dig it up, we burn it. Now we're putting extra CO2 into the atmosphere and we're kind of unbalancing the cycle, right? Now, volcanic activity, this plays a role into it as well. When volcanoes erupt, it puts a lot of CO2 into the atmosphere. But what we're doing right now, digging up and burning these fossil fuels, we're throwing this cycle out of whack where, one, we have way too much CO2 in the atmosphere now. Also, for cutting down trees, they're not taking it in, and respiration is of course still happening. So now there's a kind of imbalance between the amount of CO2 in the atmosphere and what needs to be in other places. So the cycle is still occurring, but there's kind of some issues with this cycle right now. So, whoops, we'll just get rid of that. All right, now the oxygen cycle, didn't outwardly mention the oxygen cycle, but it's tied directly to the carbon cycle because as we exhale CO2, we of course breathe in O2, oxygen, and then opposite for plants. As plants produce oxygen, they take in CO2. And we find oxygen in pretty much all of the cycles, right? We're going to find oxygen in carbon dioxide with CO2. It's part of ozone, which protects our atmosphere from UV radiation. It's found in water, so it's found in the water cycle. It's found in glucose. It's part of living things. It's found in rocks. It's part of the phosphorus cycle. It's part of the nitrogen cycle. So oxygen is part of all of these cycles, but it's most closely linked to the carbon cycle because once again, as we're breathing out CO2, we're breathing in oxygen. As plants are producing O2, they're taking in CO2. Now, this leads into the human impact on the carbon cycle. I talked about the human impact on the hydro cycle. Here's the human impact on the carbon cycle. Well, the greenhouse effect is a natural effect that occurs whether we change anything or not. Basically, gases like carbon dioxide, methane, water vapor, these are greenhouse gases. And what they do is they insulate the earth much like a greenhouse. So what a greenhouse does, sun comes in, bounces back, and the special greenhouse roof will actually keep the heat in there. That's why greenhouses are always so warm. Good environment for growing various plants. This is also a really, really good thing. This is the misconception here. The greenhouse effect is vital. Without the greenhouse effect, the earth would be really, really cold and pretty much unlivable. So the greenhouse effect is super important because we're trapping solar energy to keep our world at a good temperature. So greenhouse gases aren't inherently bad. They're a good thing because they keep the world at a good temperature. However, too much of a good thing can lead to some problems. So here are some greenhouse gases and examples of where they come from. So number one, methane. A lot of it actually comes from cattle, funny enough. Chlorofluorocarbons, we don't see these as often, but they're found in aerosols and refrigerants. Carbon dioxide, obviously a big one here, and water vapor as well. So like I was saying, now we're going to get into, okay, too much of a good thing can lead to climate change. So over the last 40 years, our levels of CO2 have over tripled, okay? In that time, the global temperature has increased by over 1 degree Celsius. And 1 degree, you're like, oh, what's the difference between 17 degrees and 18 degrees? We probably won't feel it, but some species will. Even a couple degrees change can really, really impact species out there, plants, animals, fish, etc. So what we've done is, like I was saying, we've thrown this whole balance off, right? We're putting way too much CO2 in the atmosphere. Now it's trapping more heat, it's trapping more radiation, and now it's warming our planet. This leads into the idea of climate change and then global warming, which is simply the sun, right? UV rays, greenhouse gases trap them, and now our Earth warms up because of it. Also, the more CO2 we burn, the hotter it's going to get, especially if we continue to rely on fossil fuels. So, like I said before, greenhouse effect, not a bad thing. We do need it to survive. However, too much of it can lead here to climate change and global warming, which is starting to be a pretty big issue that we're facing as humans. So that's all I have for you today. Next lesson, we're going to talk about the nitrogen cycle, so how nitrogen cycles in our biosphere, and then finally how phosphorus cycles in our biosphere. So thanks again for watching. We'll chat soon.